Um, a quick question, like, have you been there before to this presentation at CCC? Okay. Because why I'm asking is because this is a good example of me, at least in my opinion. It's a good chance for me to get the feedback from the team and looking at the interest of the audience. We have evolved this feature, external compute deployment, at that time to this extensions feature. So I won't be like talking about that feature because that's no longer there. Now it's all extensions feature. What we have done with this is we should be able to get the external system plugin into the CloudStack easily. That's the whole idea. We don't have to actually write the Java code or even build the build CloudStack. Even don't have to restart the management server. It's just that we need to have a couple of scripts that can be easily written by the operators. It don't have to be the developers also. So that's the whole idea, and we at the end we should be able to integrate anything into CloudStack. Um, that sounds like a bit exaggerating, but that's what we did. And I'll show you a couple of examples what we have done with that, and at the end we'll have a demo as well. So yes, so what we can achieve having this extensions framework, basically which can be added anything into CloudStack easily, right? So where we have started is adding an extension of type orchestrator. So basically any external system which can orchestrate instances. For example, Proxmox, Hyper-V, Firecracker, Bare Metal, anything actually. Because I'll give you an example. Yesterday during the hackathon, we got a question like if we can do the DB as a service using this extension feature. Yes, we can do that. And Suresh, if he is here, he has done it in a couple of minutes, I think. He just written a couple of scripts and made it work with the extensions feature. It may not be completely production ready or anything, but it's as simple as that. He just wrote the scripts and made it work with CloudStack. And also on top of the extensions, like we can also define the custom actions for each extension. It's like the dynamic APIs. We can define the APIs and we can run it on those extensions or the resources within that extension. For example, if I have added a Proxmox extension, I can create my own custom action. Let's say for taking a snapshot, I can run that custom action on an instance which is linked to that Proxmox instance. It's like writing a whole feature itself, right? That which can be done using the simple script itself. It can be binary as well. I'll go into the details like what are all we can do with that. And currently, we have done it with the orchestrator type for the extension. There is a big scope for the other types as well, let's say network, storage. Even yesterday in the hackathon, we had a chance to discuss the scope of it, and it seems pretty much possible doing that. Yes, here is our guy who has developed this extensions framework. I think Abhishek is here. If you can raise a quick hand, please. He has made it as solid as him. So yes, to make it simple, this is how it works. Like given CloudStack and the external system, there will be extensions part in the middle, which are the scripts, which will act as a bridge in between these two, CloudStack and the external system. So yeah, this is available from 4.21. For 4.22 as well, we have improved it a lot. You can give it a try. By any chance, anyone has tried it before? Okay, okay, thank you. I hope to see more hands for the next conference. Yeah, let's go into the bit details of it. So like I said, currently we have the extensions of type orchestrator now. Like I said, the communication between the CloudStack and the external agent happens using the JSON structured payload. So even I'll show you like how that JSON structure will be passed to the external system. Oh. So the scripts I am talking about, they have to be on the management server at this specific location. So we can have as many extensions as possible. For each extension, we can keep that scripts in this specific location. And the data that we are talking about, the JSON structured payroll, right, that will be available in this extension. So why we need to know about these locations is because at the end we'll have to write our own scripts. So we need to know what CloudStack is sending as the JSON payload, so that we can able to parse that JSON and do our own job in that scripts. So this will be the location, so that we can give it, looking at those JSON payloads, we can have our parsing and write our own scripts there. Okay, overall, this is how the workflow looks like. Let's say the operator has to do a one-time operation of writing the extension script and add it into the CloudStack. How it works like is, we need to add an extension and register it with a couple of resources in CloudStack. I'll show you an example for this as well, what are all the resources will look like. And we need to add some supporting services for that. Once this is added, for the user, it is nothing different like using the other hypervisors. If let's say if I have to just deploy the instance, I just need to select the type, select the template of type extension. That's it. It will be the flow. User won't be seeing any differences whether it is an external template or a hypervisor or anything. It's normal workflow for them. Yeah, this is an example. Let's say if I have to add the Proxmox integration into CloudStack, by the way, which is already there under the built-in extensions under CloudStack. So if I have to write this extension, what I need to do is I'll have to write the script, which is at that point. We'll have to just define a couple of methods there: create, delete, start, stop. So then, since this is an extension of type orchestrator, this is all about handling the VM life cycles. So those are the methods that we need to implement in that script. Create for the creating the instance and rest of the operations. So as an operator, I'll have to add that Proxmox extension into CloudStack using CloudStack APIs or UI. Once it is added, I need to register that extension to a cluster. Why we have to use the cluster is because to get it fit into the CloudStack flow. See, we are adding the Proxmox integration, right? It's like adding an external hypervisor into CloudStack. In CloudStack's workflow, we need to have a cluster and a couple of hosts in it. So those are the additional resources that we need to add. We need to add a host under that extension, under that cluster, and we need to have a template registered. So once these are done, user will have to just trigger the user VM deployment operation using that template registered under that extension. So when the workflow will be like, user will trigger the operation, the CloudStack will send the JSON payload, let's say all of the details that are required to deploy the instance. So from CloudStack point of view, the details that we will be passing is let's say all the VM name details. And let's say if I have selected an isolated network, we'll all send the network details so that we can handle, we can parse them in the script and deploy that instance in the Proxmox environment. On top of the extensions, as I said, we can have the custom actions we can define on the each extension. This is more or like defining a dynamic API. So I can have let's say when I try to create a custom action, as an example, if I want to take the snapshot of the Proxmox instance, as an operator, I'll have to define the custom action on the extension saying take snapshot, and there is we can define the user inputs as well. What are all the user inputs that will be needed while performing that action, and we can define the success and error messages. And also we can set what are all the role types that are allowed to that action. This is more or like developing the API itself, right? But we don't have to do that with the Java code, but using these custom actions, we can directly define it. Once that is done, yes, we can run that custom action. We'll show it. As an example of this workflow, the operator will have to add the custom action. Let's say if it is for Proxmox, as I said, it's the snapshotting. That will be registered on extension. User will just use that API to trigger that action. All we need to do is, in that extension script, we'll have to add the corresponding method to do the corresponding job, to perform the job using that extension scripts. So this custom action will be transferred to the extensions, and there we need to have a handler in it. if we look in a different way, the orchestrator extension, right? It's all about adding an external hypervisor, like we do normally do it for VMware and KVM. So as a built-in extensions that we have already tried, we have added Proxmox Hyper-V in 4.21 CloudStack version, and in the bare metal mass we have added it in 4.22. So that's documentation is all available, and you can give it a try if you have a Proxmox or any of the other environments. So using those extensions, you can deploy the instance, do all other VM lifecycle operations, and even you can define the custom actions. One other optional thing that we can do is, let's say, if I have to deploy the instance from CloudStack, all I need to, the reason why I have to deploy it from CloudStack is that instance, Proxmox instance, has to be in the network that is defined in CloudStack. So those network details will be passing to the Proxmox instance, right? Let's say if I have to get the MAC address from the Proxmox environment, and I'll have to configure that MAC address in the virtual router, in the CloudStack's virtual router. So as an optional operation, we can enable or disable whether we need to get that MAC address or not from the external system. Yep. Again, these are the two people who have built these built-in extensions. Abhisar, our dev guy, and Kiran, our QA guy, and they are all in pretty much working state. I'll now quickly go through the couple of screenshots, how it looked from the CloudStack UI. As I said, we'll have to create an extension first in CloudStack. For example, if I have to add a Firecracker extension, it's just filling up the name and details part, and the path will be there, path of the script that we need to write on our own. And we need to select the type orchestrator. Currently, only one type is available. Later on, we can have network and storage as well. And this is the optional parameter I'm talking about, whether we need to prepare the instance or not. Before actually deploying the instance, whether if I want to get some details from the external system, we can use this flag, if we want to do that or not, whether to prepare the instance from CloudStack. And also, we have given this optional metadata as configuration details. We can add any metadata that we can add it to the extension. So, for example, we are talking about CloudStack and an external system. So, in the scripts, I need to some way have to contact to the external system, right? Let's say if it is Proxmox, I need to have some credentials to be passed to that script so that it can access that Proxmox environment. I can have multiple Proxmox environments, and I can have multiple extensions. So all of that different metadata can be added as a configuration details here. And those will be passed as a JSON payload to that script. And once that extension is added, like I have shown in the workflow, we'll have to register with the cluster. We'll have to create a cluster and of type external and register this extension to that specific cluster. And we'll have to add the host in it. These are all will be like a dummy operations. Dummy as in for the KVM and VMware, we actually do the discovery of the host and all, right? At this point, we are not doing anything in the extensions. It's just about registering the resources that are needed for the CloudStack workflow to deploy the instance. So now we will have to create the cluster, host, and if any metadata that we want to add, and service offering, of course. This metadata is available as part of adding the host as well. And yes, this is about the okay, for the user operation, like I said, this for the user, these are all not visible. It's a normal workflow. They have to select the template and deploy the instance. And this is how it looks like for the custom action. Once the operator has defined the custom action on the extension, for the user, let's say he has already got an instance, and when there is a UI button and API further to run that custom action, and couple of parameters which our operator has already defined, they'll have to pass those parameters. as we have already talked this, if it is a snapshot, it could be a snapshot name and maybe the path where I wanted to take the snapshot, which the script will be taking care of it. Yes. So the whole point of this extension feature is to make it easy, right? To get that external logic into CloudStack core without having to do much of the changes with to CloudStack. As I said, no need to restart the management server also. So we don't need to have a developer in place to make this work. Let me now invite our technical marketing manager. I repeat, technical marketing manager who has done this Firecracker extension. I promise he didn't ask me anything about the documentation or anything. He has done it everything on his own. Marco, please.
Thank you. Hello. Hello, guys. So the idea here is to prove that a technical marketing manager can do an extension as well. It's very simple. This framework helps to integrate everything as a service into CloudStack. So about me, so I am committed at Apache CloudStack, working more than 25 years in the IT area. So I started with a sysadmin a long time ago in 90s. And my career was working with virtualization, Linux operational system. After I left all of this to work with the cloud, sales side and marketing side now, but I continue with one foot on the IT area because I love to explore this stuff. But a long time I'm not programming, so this work I did using Codex and Cursor to write the code just as a proof of concept. So use it with caution. I think it needs some review. To use it in production is an experimental extension, so need testing. You can run it in a non-critical environment. So about the Firecracker, so it's a lightweight VMM created by AWS, so to run serverless, edge, and container workloads faster. Some function you need to run and discard the instance. That's it. It's interesting to use Firecracker. It boots really fast, so in minimal time you have it running. Some limitation the Firecracker has. They don't have an orchestration layer to create and run instance. And so my goal here with this proof of concept is CloudStack manage Firecracker micro VMs like a standard virtual machine you have into the CloudStack. So the architecture I did for this to integrate Firecracker with CloudStack is first in this, I think I have a light here. So the first is the Firecracker Python script in the CloudStack site. This is the extension. After, in each host, I have an agent serving HTTP server with authentication, TLS, and a RESTful API to control the Firecracker into the roast. And so I can, in that way, create micro VMs as I need it. Some capabilities, so endpoint using RESTful API. I developed some backends for storage file, LVM thing. To be faster, I think LVM thing make more sense because you can clone it faster and boot faster than micro VM as well. Network Linux bridge with VLAN and Open vSwitch with VLAN as well. So I have a process with using tmux to provide a serial, and so in that case I can expose it to VNC console. I show it after. So the operations is then pointed with persistent state on the host. If the host reboot, the VM continue there, you'll be shut down. You need to just go to the CloudStack UI and start the instance. Authentication, as I told you, using the PAN authentication, and TLS and MTLS encryption for the endpoint. And I do a very short demo just to show it working that a market guy reached to do an extension for CloudStack. Let me just check here. Is that Darwin? Maybe? No. No. Ah, this one. Where is I? Is here, right? Display settings. Wait a minute, I will show it. Just back here. Here. Okay, okay. Display. Extended. Mirror. Okay. This mirror. Okay. So I already have some instance running here. It's a Firecracker instance. Let me just show what exactly I did. The first thing you need to register the extension. It's not built in, so I have this extension here. This is the Firecracker with just defining it, and the path is this one here, type orchestrator, etc. And after my infrastructure, I have the cluster, Firecracker cluster here, hosts. I have 2 Firecracker hosts where I needed to authenticate. So in that case, I'm using the URL endpoint to connect to the RESTful HTTP server. The PAN user, in that case, I'm using Ubuntu, the port, and the password to connect there. So everything is here. And templates, in that case, I have 1 template, Alpine Linux, because it's faster to boot as well, the Alpine Linux, with some characteristics here, with the boot arguments, the image I'm using, and the kernel. That's it. It's enough to have a functional Firecracker extension working. So when I need to add a new instance, like a regular user, for example, I will select my Firecracker instance. So I will select the compute offer I want. I can use SSH key pair as well, define a new name. So we just launch it. The 7 is here. 1, 2, 3, 4, it's running. I can prove that. So I can access the console proxy here. Here, booted. It's all I need to show, guys. That's it. I think everyone can write extensions to the CloudStack, so that's it. Let me go here, yeah. So just something, new types, network authenticator for the extensions, right? The new type you want to do. Some improvement in terms of usability, feedback from community. Your community is important to feedback us. And do some marketplace. Some part is ready about the extension marketplace.
This is the one you have guys done in a
exactly.
hackathon.
The guy is working yesterday in the hackathon. It's a manifest file for external GitHub repository to install it automatically. So that's it.